These are the 5.4 notes for Algebra 2. We're going to talk about solving radical equations today. So for our first example, we have the square root of x plus 3 equals 5. To get rid of a square root, we're going to square both sides. Now this is important, you have to have that other side in a parenthesis. So if you want to do both sides in parentheses, that's fine as well. A square root and a square cancel, giving you x plus 3 equals 25. Then you would subtract 3 from both sides, and you would get x equals 22. Now the thing about square root problems, you do have to check them at the end because every once in a while you'll end up with something that we call an extraneous solution. Extraneous solution. So we're going to check for extraneous solution. Extraneous is just coming from the word extra, so it's an extra solution that means you did the math correctly, but for some reason when you plug it back in, the answer does not check out. So what you would do is you would plug 22 in for the original problem right here in the x. 22 plus 3, and we have to make sure it gets us back to 5. Now you don't want to go any further into the equation, like you don't want to be writing this step down when you check it. You need to be writing down this very first step, the original problem. I add 22 plus 3 to make 25. I'm just going to drop down the 5 with each turn. Just keep dropping it down. The square root of 25 is 5. Drop it down one more time. 5 equals 5. Yes, it does, which means that this answer is correct. All right, now this extraneous solution happens when you're squaring something. So as we look at example number 2, you'll notice that you have a cube root. And this issue does not happen during a cube root. So anytime you have a cube root, we just say no check needed. So I know whatever answer I get is going to be correct. This one is a cube root, which means in order to get rid of that cube root, I'm going to take it to the third power. I'm going to cube both sides. So whatever root you have, you match the exponent. Those cancel. And negative 2 to the third power means negative 2 times negative 2 times negative 2, which will give you negative 8. And then we add 4 to both sides. X equals negative 4. And again, because it's a third root, there is no check needed. Let's move on to example 3. When you see a 1/2 power, 1/2 exponent means the square root. 1/2 exponent means the square root. So the first thing I'm going to do is I'm just going to rewrite that using a square root. Then to get rid of the square root, I will square both sides. The square root and the square cancel, giving me 2x minus 7 equals 81. Then we add 7. To get 2x equals 88. Then we divide by 2. X equals 44. Now, because this was a square root problem, we do have to check it. So we can check it in the problem as long as it still has the square root in it. 2 times 44 minus 7. And we want to make sure that equals 9. Two times 44 is 88. Drop down the 9. 88 minus 7 is 81. Drop down the 9. The square root of 81 is 9. 9 equals 9, which means that this answer is correct. Example number 4. Start immediately by squaring both sides, raising it to the power of 2, which will cancel the square root and the exponent of 2, leaving me 3x plus 1. When I do negative 4 squared, that means negative 4 times negative 4, which gives me a positive 16. Subtract 1. And divide by 3. I do have to check this one because it's a square root. So I'll put it back into the original problem, 3 times 5 plus 1, and we'll see if that gives us negative 4. 3 times 5 is 15. Bring down the negative 4. 15 plus 1 is 16. Bring down the negative 4. And the square root of 16 is 4. And notice right there, 4 is not equal to negative 4. Which means that this is not an answer. It's what we call an extraneous solution. So if that 5 is not an answer, then I don't have any answers, and I write my answer as no solution. If I threw out my only answer, then I have no solution. All right, let's move on to the back side. Example number 5. For this one here, notice this 5 is not underneath the square root. You want to move that 5 to the other side first. So move the number not in the root bar. All right, and then you'll raise this to the third power to match the root of 3. The 3's cancel, giving me x plus 9 on the left-hand side. 1 to the third power, 1 times 1 times 1, that still leaves a 1. And then you could subtract 9. We get x equals negative 8. And because this is a cube root, there is no check needed. And the reason we don't need to check a third root and we do have to check a square root, think about it like this. Let me get a different color for you. When you square something, when you square like a negative 3, when you square it, it becomes a positive 9. The negative is gone, it disappears. But when you cube something, the negative stays around because 3 negatives still make a negative. So on this one, you've got the negative taken care of. But here, the negative disappears, and that's when we run into some trouble. And that's what happens when you square something. So if you're squaring a negative, that's when you might get an extraneous solution. Just something to think about, a little explanation of why we don't have to check those, but we do have to check the square roots. All right, example number 6. We'll start by moving over the number not inside the root bar. So subtract 4. And then we'll square both sides. And based on what we just talked about on the previous problem, This situation is about to happen. You see it, negative 8 squared is going to give me positive 64. And that's going to create a problem later when we check it. Subtract the 10. And divide by 2. X equals 27. Okay, so already I'm a little suspicious because of this right here. Let's go ahead and plug it in and see what happens. You can plug it into the equation as long as it still has a square root bar in it. So you could plug it in right here, or you can plug it in right here, but you cannot plug it into that one. Right, so it has to still have the square root in it. I'll go with a very original problem. 2 times 27 plus 10 plus the 4 equals negative 4. 2 times 27 is 54. Remember, I want to keep that negative 4. Whatever's on the right-hand side, I just want to keep that the whole time. 54 plus 10 is 64. The square root of 64 is 8. And 8 plus 4 is 12. Notice I kept the negative 4 the right-hand side. I kept it that same thing the whole way down. 12 is not equal to negative 4. Which means when I checked it, turns out that this is an extraneous solution, an extra solution. So that means if I threw out my only solution, I have no solution. And again, you had a feeling right here when that negative disappeared that that was going to happen. Okay, example number 7. This time we have a 1/3 power. 1/3, just like 1/2 means square root, 1/3 means cube root. 1/3 means cube root. So I will write that as the cube root of 5x minus 3 plus the 7 equals 10. And remember, we need to subtract our 7 because it's not under the root bar. You get the third root of 5x minus 3 equals 3. To get rid of the cube root, you raise it to the third power. And same thing on the other side. Those cancel, giving us 5x minus 3. And then 3 times 3 times 3, 27. Now we're back to just a regular linear equation. 5x equals 30 and divide by 5. X equals 6. Remember, for these cubes, we don't have to check. So just write a little note, no check needed. If you don't write a little note or a little something there, then it just seems like you forgot to do it. So just make sure you write a little note. All right, and our last one, example number 8. This is a good time to pause the video, see if you can do this problem, and kind of fast forward to get the correct answer. Hopefully you had a chance to try it. I'm going to go through this one pretty quickly. Start by subtracting 2. Square both sides. Add 7 to both sides. And divide by 4 to get x equals 4. I will have to check this one because it is a square root. So I'll check it all the way back in the original. 4 times 4, so I plug the 4 in for that x, minus 7. And then the plus 2 is a little bit separated, equals the 5. Again, we want to keep that 5 there the whole time, so we'll just drop it down with each step that we do. Over here, we've got 16 minus 7 plus the 2. 16 minus 7 is 9. Keep dropping the 5 down. Square root of 9 is 3. Keep dropping the 5 down. And at the very end, 3 plus 2 is 5. So I have 5 equals 5. That is correct, which means that this is a correct answer.